with Venn diagrams from the Boolean point of view, when it comes to the categorical propositions, if I say all S are P, what it's actually meaning is that no members of S are outside of P. And if you look at it, it says all S are P. It's saying that every single member of S also happens to be a member of P. So therefore, no S's can be outside of P. Now, if we go to no S or P, what it says is that no members of S are inside of P. So it's saying that all members of the S group are totally separate from all members of the P group. Now, if we go to some S or P, at least one S exists, and that S is also a P. Okay? Some S are not P. That's saying that at least one S exists, and that S is not a P. Now, when we get to the circles, make sure you write these down, because when we get to the circles, it will make absolute sense. So, besides writing these out in this form, we can draw them in circles to represent the same information, and that's what we're going to do, which is going to be very helpful because as we go on, we can compare propositions to one another using Venn diagrams, and also gives you another way to check your work from the Venn diagram to the written form. Okay, so the Venn diagram, this is from the Boolean point of view, and it's the modern square. And so we have two circles. The first circle is always the subject. The second circle is always the predicate. So when you're doing these, working them out, always make sure you put the subject as the first circle and the predicate class as the second circle, okay? The members denoted by each term should be thought of as situated inside the corresponding circle. So when I'm talking about members of S, it's everything inside of this circle, okay? If I'm talking about members of P, it's everything inside of this circle. So the members denoted by each term should be thought of as situated inside the corresponding circle. That's very important. And so here's an illustration of that. Okay. So first of all, we're going to start off with our subject is American. Our predicate would be farmers. Okay, so if I have a Venn diagram, okay, I have my two circles. My subject would be American. See, so I put S in the Americans. Predicate would be the farmers. It comes second. Okay, so everything that is a 1 is an American. Everything that's in 2 is an American farmer. And everything that is in the 3 area is just a farmer. So hopefully you can see that, okay? Because 1 is an American, 2 would be an American farmer, and 3 would just be a farmer. And the reason is because when these overlap, that is where you get an American farmer. Okay. Just give you a second to look at that. Okay. Now, with Venn diagrams, and again this is from the Boolean point of view, there are two kinds of marks used. You have shading. Shading is used for universal propositions, and shading means that an area is empty. Okay? Shading is used for universal propositions, and it means that an area is empty or it doesn't have any members in that portion. Okay? Second kind of mark is used is an X. An X is used for particular propositions. An X means that at least one thing exists in that area. Okay, so an X is used for particular propositions, and an X means that at least one thing exists in that area. So let me give you an example of all the categorical propositions. Okay. So, if I have an A statement, and remember again, an A statement, all S are P. Remember the subject goes first, is in the first circle, and the predicate's in the second. So if I say all S are P, and I'm marking that in a Venn diagram, this is what my Venn diagram is going to look like. All is a universal proposition, and with universal propositions, you use shading. Shading implies that an area is empty. So if I say that all the S's are P, The only places that S's can also be P's is where they overlap. So this area has to be empty. So that way it shows that all the S's are right in here because all the S's are also P. We come down to the E statement, no S or P. So that's another way of saying all members of S are separate from members of P. So the shading is going to go right here, and it's shading because no is a universal principle. Shading implies emptiness. And if no S or P, this area has to be empty. So I'm saying no S or P. All the S's are over here because they are separate from the P group. So this is the only way to express this statement is with this Venn diagram. Now I move down to an I statement. Some S or P. Now with a particular statement, you use an X. And that applies at least one exists in that area. And here it says some S or P. Well, we know it's an X because it's particular. The only place where an S can also be a P is right here in the middle where both circles overlap. So I'm going to put an X. Now we move down to O. Some S are not P. The focus is on the S's that are not P. Okay, the focus is on the S's that are not P. The only place where S's are not P's would be in this first circle, right where the subject is by itself. So the X would go here. Okay? Now, here's our little cheat sheet that I have found handy over the years. And you're probably going to just want to pause it so you can write this down. Okay, but here's the Venn diagram again. So the subject circle goes first, the piece is second. Now I've numbered them to make it easy because Venn diagrams are just like color by number. And you remember those, you've probably done one in your lifetime. You know where 1 is red, 2 is blue, 3 is purple. So every time you see a 3, you're supposed to color purple. Every time you see a 4, you're supposed to color yellow. It's the same every time. It's the same way with Venn diagrams. It never, ever changes, which is a great thing. If you figure out how to color stuff in or where to put an X, it never changes the whole time. Okay? So here's a cheat sheet to help you. Okay, I've labeled the areas 1, 2, and 3. Okay? 1 equals the subject only. So if I have the 1 area, only the subject can be in that area. Number 2 is where both circles overlap. So in the 2 area, we have an S and a P. That's where S's and P's are together. Now in the 3 area, that is where P's can exist only. Okay? Now, when you're making markings, if you're marking an A or an O, you're only going to put shading or an X in the S area. If you're marking an E or an I statement, you're only going to use shading or an X and put it in the number 2 area. Okay? So an A and an O, those markings only go in a 1. The E and the I only go in the 2. That never, ever, ever changes. Okay? And just remember, shading equals empty. You use that for universal propositions, and X means at least 1, and that's for particular. So let's do an example. So let's say that I give you this proposition that says no pigs are astronauts. No pigs are astronauts. Now, here's my Venn diagram. Pigs is the subject, and if you remember, pigs is the subject because it comes first, and there's the copula. So the astronauts would be the predicate. So I put P for pigs, that's the first circle because it's the subject. A is the astronauts, it's the predicate, so it comes second. To diagram this statement on here, you have 2 questions you're going to want to ask yourself. The first question is, am I going to use shading or an X? That's the first question. Once you determine that, then you ask the second question, where am I going to put the mark? Okay, so this ends part 1 of the video, and part 2, click on it so we'll work from here.